Alright guys, let's knock out these worksheets. This table goes with number 1, and this graph goes with number 2. Okay? Now, we've got to get an equation. So this one's going to be y equals 1, 3 to the x power. Okay? Now, if you notice, we're timesing 3 every time, so that's our ratio. It's going to be 3. Now, I know you're going to say, well, our starting one is 0. I get that, but hear me out. It's got to be 1. I say 1 because if I raise this x to the 0 power right here, well, 3 to the 0 power is going to be 1, and 1 times 1 is 1. If I put this as 0 here, I mean, let's face it, all of these would be 0. So just take my word for it, it's going to be 1, okay? And it works out. So our domain, again, is going to be all real numbers. If we're talking about an equation, y'all can't see that. Let me fix that. Is this better? All right, let me just changing my ink pen here. All right. Remember, it's going to be all real numbers, but in this case, for what we're working with, we're going to say 0, 1, 2, and 3. Okay? Now, I say all real numbers provided if this thing keeps going and going, but, you know, based on the table, we have to say this. Same thing for the range. We're going to count the 0 because we can plug the 0 in this equation to get an answer, which is 1. So, again, if this thing is going everywhere, we're going to put all real numbers, but based on the table, we're going to say 1, 3, 9, and 27. Okay? We put boxes on them because we're including them. Let's see, what's next? X-intercepts. Again, since this thing is increasing, okay? Hey, wait a minute, this thing's increasing. So that's what it looks like. So I can't say they're all real numbers, can I? Because they're not going to have any negative y's. Okay, in fact, I have to say it's going to be from 0 to infinity. Dagnabbit. Where was Javon when I needed him? Alright, moving on. X-intercepts. Well, the fact that I just said our range is going to be to 0, approaching 0 but never touching, that means we don't have any x-intercepts. Y-intercepts, on the other hand, well, that's going to be 0 and 1, because if x was 0, our graph is going to be 1, so that's right here. So 0, 1. And based on what we were talking about on the rate of change yesterday on the video, we're going to say, oh, rate of change, I skipped a question. It's increasing. All right, rate of change, 1 to 3, okay? 1 is going to correspond to 3, and 3 to 27. So I'm going to write it like this. Let me move it down just a little bit. 27. So our points is 1 and 3, 3, 27. So your formula will be 27 minus 3, all over 3 minus 1. Okay. So that's 20, what is that going to be? 24 to 12. Boom. Okay. Now the graph over there, they're telling you it's half every time. So that equation will simply be y equals half and all that raised to the x power. Okay? Domain, well, that's going to be all real numbers. We've talked about that 100 million times. Range, on the other hand, we're going to learn our lesson from the last one. Approaching 0 and then goes to infinity. X-intercept, since it's approaching 0, that means there's none because it's not going to cross the x-axis. Y-intercept, if I plugged in 0, we get 1. That's right here, 0, 1. This is decreasing. And if I plugged in -3, we get 8, and I say that based on this equation. If I plugged in negative 3, excuse me. If I plugged in negative 1, we get 2. Again, use your calculator to figure that out. So, using my rate of change, I go 2 minus 8, negative 1 minus a negative 3. Forgot my line. So, 2 minus 8 is negative 6. That turns into a positive, so negative 1 plus 3 is going to be 2. This should equal negative 3. Makes sense because it's going down, decreasing, which means our rate of change should be a negative. Just like this increasing, our rate of change was a positive. Okay? Let's move on to number 3. The Honey Baked Ham store, ham, tracked how many hams they sold for Thanksgiving during the month of November. If they sold 2 hams on the first day and sold 4 times as many each day, answer the following questions and graph the equation. All right. Let's see here. So first day, 2 hams. So 2, 4 times as much. So 4 is our ratio. Raised to the x. Okay. I'm going to say this is discrete because you can't sell half a ham unless we're selling slices. Domain. Well, we can't sell 0 hams to infinity, depending if the hams last that long. The range, well, we started off with 2, and again, that could go to infinity, depending on how many hams we have. X-intercept will be none. Y-intercept will be 0, 2, because that's where we start. This will be increasing, because, we're selling hams. The more I say ham, makes me hungrier, and I have not eaten supper yet. Rate of change. Well, using the formula, if we plug in 3, we should get 128 out. If we plug in 6, we should get 892. 8,192. You need to try this out. Plug it in. Okay? But you know what? We need a T-chart so we can graph. So 0 is going to be 2. 1 is going to be 8. And guys, I figured this out because I plugged it into my equation. You can be doing the same. Don't just copy me. Try this out. Pause the video and finish it. Start it again to check your answers. Alright? Don't just copy me. You're not going to get anywhere that way. So if I want my rate of change, going back to this, all over 6 minus 3. I just plugged all that in my calculator, and I got 2,688. Okay, you can plug all this in your calculator. Hit the fraction key, make it look just like this in your calculator, hit enter. Now, before I get carried away, we need to graph it. So 0, 2, down in here. 1, 8, that'll be right here. 232 would be cheer, and 3 would be 128, which is, well, that's just off the graph, about up in here. I'm not going to connect this because we said it's discrete, meaning you can't sell half a ham, so I'm just going to leave it as dots. Okay? Alright, let's move on. Number 4. Okay, a Dalmatian puppy is born with 10 spots. If the number of spots increases each year according to this chart, answer the following questions. Write an equation to represent how many spots a Dalmatian will have. So, starting is going to be 10, and we look like we're doubling it every time. So, y equals 10, doubling it every time to the x. Take note, you can also write it like this, f of function, f of x, 10, 2 raised to the x. They're one and the same, okay? I need y'all to start recognizing that. Alright, so we got an equation. Calculate the average rate of change between 1 and 3. 1 and 3. So that's 120 for the sake of our points. And then use your rate of change, so 80 minus 20 over 3 minus 1, and we get 60 over 2, which is 30. Calculate the average growth rate first 5 years, 0 to 5. Well, again, 0, 10 on my point. Second point is 5, 320. Again, set it up in your rate of change, so 320 minus 10, all over 5 minus 0. You get 310 over 5. This equals 62. Okay? Which average growth rate is higher? Does this make sense? Well, we're going to say between the 0 and 5. Okay? We say this because, yes, because it's a longer period of time. Longer period of time increases as it gets older. And this has to make sense because let's face it, the dog will be bigger, more room for spots, so the spots increase. Okay? Dalmatians are so cute. Number 5. Fall is upon us, and the leaves are changing colors. If 2/3 of the leaves on a tree are remaining after each week, use the graph below to answer the questions. So y equals, looks like our starting point is 900. And it says it's decreasing by 2/3. And you raise all that to the x power. Again, I want y'all to get used to this, so it could say f of x, 900, 2/3, all raised to the x. There we go. So describe the domain and range of the function. Well, domain, we're starting off at 0, and then we're going on to infinity, as far as the weeks go and whatnot. Range, on the other hand, we're starting off, well, remember you got to read from the bottom up, so that's going to be 0, approaching 0, but it stops at 900, so we're going to put a bracket around that. Okay, so domain 0 to infinity, and then range down, up, so 0, and we stop at 900. Calculate the average rate of change for the first 7 weeks, 0, 7. So, again, let's get some points, 0, 900. Because remember, these are x values. Plug in 7, and we get 50. And I'm basing all of this off of the graph. 750, and that's 0, 900. Plug it in. Oopsie daisy. Now 50 will be first because that's the second point. 50 minus 900 all over 7 minus 0, and we get negative 850 all divided by 7, which gives us about negative 121.4. Okay, that makes sense because it's decreasing. It should be a negative. How many weeks will it take for there to be no leaves left on the tree? Hint, use your table. Okay, so if we were to make a table, and I mean we're just gearing this out, we're looking at 17 weeks. Okay, because then you would have, after 17 weeks, and you knock this out with your table, you'll have less than one leaf. You got to work this out, okay? Start at 10, and then keep going until you get less than one leaf, okay? Here, just to show you, 10 is going to be, I'm going to plug it in. Excuse me. Guys, I tell you what, I'm starving. The things I do for you guys. So I got 15 here. 6, 1. Keep going. Change it to 11. This one's 10. Keep going until you get less than 1. Okay? Alright, moving on. Comparing multiple representations. I gotta take a break. Alright, I'm back. So again, we're practicing more, okay? This table is going to be used for this equation and this equation for these questions. So, let me write an equation. Sorry about that. Computer was slowing down. Y equals 512. Notice it's going down by half every time. So 1/2 x. Again, domain, all real numbers in this case. The range, well, it's going to be from 0 to 512 because that's where it started. Okay. In fact, I would argue this range to start at 0 and then go into infinity, to be honest. Okay. So x-intercepts, as always, is none because it's not crossing the x-axis. Y-intercept, well, that's where it crosses 0, 5, 12 because that's where it starts. Now, since the numbers are going down, it must be decreasing. Rate of change, we got to get our points. So 1 would be 256. 4, well, I'm going to plug that in and I get 32. And I can just look at it, it's half of 64. So stack it, 32 minus 256 all over. 4 minus 1. And we get 224 over 3. Negative. And then if we were to hit the SD button, we would get negative 74.67-ish. Okay? Over here, since we're not using a table here, I'm just going to go ahead and assume that it is all real numbers this time. That's a terrible one. Let's do this. Haha, that looks a little better. Range, well, again, I know it's going to be approaching 0 because I've seen plenty of these already. And look, you can plug this stuff into Desmos and it'll give you the same shapes. It's not going to cross the x-intercept. It's not going to cross the x-axis. Y-intercept, well, it's where it starts, 0, 2. And I say where it starts, but I'm plugging in 0 for x. I work it out and I get 2. I know it's going to cross the y-axis at 0, 2 because I plugged in 0 for x and I get a 2 out. Increasing or decreasing, I know it's increasing because my rate is greater than 1. So find the rate of change. So if I plug in 1, I get 4 back. And if I plug in 4, I get 32 back. So plug this in, I get 32 minus 4. and then 4 minus 1, and I get 28 over 3. Okay, and decimal wise, that's about 9.333. Okay. The next one, using the equation characteristics from number 1 and 2, answer the following questions. Y-intercept of fx and y-intercept of gx. So f of x was 512. Remember, g of x was 2. Well, that means that has to be greater than. If I plugged in f of 4, I get 32. If I plug in g4, or g of 4, I get 32, so that's equal. Remember, I'm going back to question 1. This was on the left side, this was on the right side. You see? Here, why don't we write that? Left side, right side. Back on problems 1 and 2. Alright, rate of change, we figured that out. We said that was 74.67, and this side was 9.33. So, again, that'd be greater. That was easy. Hillgrove, and what was that? McEachern, I guess, are having a competition to see how many students they can have retweet a rumor about other school. Hillgrove has 25 kids originally retweet the rumor, and then 3 times as many kids retweet each hour after a while. McEachern's retweets are represented by the table. Whew. Write an equation for each school and answer the questions. Yikes. That was a mouthful just to read it. Hillgrove said they start off with 25 kids, and they're retweeting it every 3 times, or 3 times. A ratio. McEachern over here, that's what this one's going to be. Well, they start off at 15, so here's my equation for that one. And if we look, to make that jump, we're timesing 5 every time. So it must be 5. Okay? Put a little x here, times 5. So, raised to the x power. Okay? So, which school starts off with more original retweets, greater y-intercept? Well, Hillgrove. Because they have 25 to start off with. Starts out with 25. Okay? And let's face it, logic behind that says 25 is greater than 15. It's a greater than symbol. Alright, which school has more students retweet during 1 to 3 hours? Guys, that's the greater rate of change, or the rock. So, I'm going to work that up here. So for Hillgrove, if I plugged in a 1, we would get 75 back. And if I plugged in a 3, I would get 675 back. When I mean plug it in, I mean I'm taking this 1, I'm plugging it in for x, I hit enter, I get 75. Take the 3, plug it in, work it out, you get 675. Then you got to do the rate of change, which is 675 minus 75 all over 3 minus 1. You get 600 over 2, which gives us 300 for Hillgrove. Okay, keep that in mind. Next one, again, I'm plugging in the 1, and I get 75 in return. And then I plug in the 3, and we get 1,875. Okay, again, use the slope formula for our rate of change. So 1,875 minus 75 all over 3 minus 1. We get 1,800 over 2. simplifies to 900. So just based on that, I hope I'm saying this right. McEachin, McEachern? Maybe it's McEachern. Has more tweets. There we go. Okay. See what's next. All right, comparing exponential functions. Seem to have lost mine. Hold on. Oh boy, guys. I almost made a big mistake. I was about to do the wrong one. See this? Y'all don't have this one. Y'all have this one. Ooh, I was about to make a bad mistake. All right, we're almost done. Then you can work on your reflex and whatnot. And I can go to bed. I mean, look at this. Look at that time. 7:42. Whew. All right, let's knock this out. Your parents give you $2,000. Ooh-wee. To start with, and the bank then doubles that amount each year. Okay? And then choice B says your grandparents give you $200 to start with, and the bank quadruples the amount each year. Write the functions for each of the options and fill out the table. Man, making bank. So the first option was 2,000. Those are starting, and it's doubling. So that's that equation. The next one start off at 200, and the quadruples. Man, this one would get more money, but let's see what happens. So, guys, all I'm doing is hashing out these numbers real quick, okay? So, 2,000, plug in 1, we get 4,000. Plug in 2, we get 8,000. 16,000 for the next one. And $32,000. Again, if you want to know where those numbers came from, you plug it in. You should be doing this as well. Next one, 200, because that's the start. 800, all right, looking good. 3,200. 12,800, want to plug in that 3. And then 51,200. Yeah, I tell you what, this one's making bank. But again, plug it in so you know where these numbers are coming from. All right, let's see what the next option is. It says y-intercept of p of x equals, well, that's easy, that's 2,000. Okay, g of x, well, that was 200. Which one's greater? Well, 2,000. It says p of 4, well, that was 32,000. We figured that out. And then g of 4, 4 years, it seems, yeah, so, yeah, 4 years, all right, this is that 51,200, and that one's greater. So over 4 years, this plan's better, even though it started off with 200. So rate of change from 0 to 4, 0 to 4 over here. Let me go back. So 0 to 4 would be this one, that one, this one, and that one. And I'm finding the rock for these two, okay? So, cutting straight to the chase here, it's going to be 32,000. What am I doing? Minus 2,000 all over 4 minus 0. Plug all that in your calculator, you're going to get 7,500. Excuse me. Over here, 51,200 minus 200 all over 4 minus 0. I think this gives us 1. Dang it, I cleared my calculator on accident. Let me punch this in real quick. 5,200 minus 200 over 4 minus 0. 12,750. There we go. So 12,750. So now I can fill these in. This one was 7,500. And this one was 12,750. And holy cow, that one's much, much greater. I don't think much, much greater is a word. But look, just because this would start off at 200, its plan was better because it's quadrupling. Okay? This one was just doubling. And I mean, granted, it started off a little stronger in the beginning, but this one outran it when it got to the bigger numbers. So think about that when you're dealing with savings. Okay? All right, we're almost done, guys. You decided that after all the Thanksgiving food you ate, yep, that's me, you're going on a diet. Nope, that's not me. Compare two plans as you start your workout slowly over the next several weeks. And I got to start working out. You start your workout with 5 hours a week and increase by 50% each week. Hint, add 50% to 1. All right. Write the equation for each plan. So your plan A, plan B. So plan A. All right, so we start off with 5 hours. So that's our starting point. And we're adding 50%. Well, they said add 50 to that. So that's 0.5 plus 1. Well, that's 1.50, right? So that goes in our rate. And that's to the x. To the x. Put the little x there. Second plan, looks like we're doubling. That one's easy. So y starts off with 1, doubling it every week. Skadoosh. Compare the y-intercepts to the two plans. Well, plan A is 5. Plan B is 1. So plan A has a higher y-intercept. Plan A has a higher y-intercept. They're starting off strong. Compared, this is probably more my speed, plan B. Let's see what else we got. Cole wants to get ready for track conditioning that starts in January. Compare how many hours he'll be working out for each plan if this season starts in 6 weeks. All right. So basically, we're just plugging these in, guys. So plan A. Get this thing out of here. Get this out of here. Oh my gosh, what's going on with the graphics? Oh my gosh. Plan A. It's going to be 5, 1.5 raised to the 6, which equals 57 hours. Plan B is going to be 1, 2, raised to that to the 6. We get 64 hours. Uh-oh. 64 hours. I picked the wrong one. I'm going to be working out all the time. Man, what's the deal with the graphics here, guys? I'm sorry for this. Ew. All the stuff's here. Let's see if we can fix it. Ah, much better. Hope they didn't catch it on video. Alright, almost done. Moving on. Number 4. 2 more to go, guys. Smell the finish line from here. Find the characteristics of each equation. This one again looks like, no, it's not doubling. That one's more, I think it's times them by 3. So y equals 2 ratio 3 to the x. Domain, again, I would say all real numbers, but since we're looking at a table here, you know, I mean, for real, we can argue all real numbers. I'll be fine if you said 0, including it, to infinity. You know, the argument can be made both ways, in my opinion. Range, since this is exponential, you know the lowest value is going to have to be, let's see, that's our equation. Well, that means it's going to be approaching 0, so 0 to infinity. Okay, x-intercepts, again, will be none. Y-intercept, well, where it crosses, so that would be 0, 2. Again, plug the 0 in to find that 2. This thing is increasing based on the ratio. Now I got to find our points. Come on, 4. Let me plug 4 in right here. We get 162. So I'm going to just go straight to the chase. 162 minus 2 over 4 minus 0. That's 160 divided by 4. That's going to give me 40. Skadoosh. Domain, again, I would argue all real numbers. Man, this one's kind of ratchet. See, that's that double backbone on that R, guys. This one, let's see, domain. There's not a table here, so really you're going to have to say all real numbers. Range, remember, it's going to get close and close to 0, but never touch it, to infinity. X-intercepts will be none again. Y-intercepts, plug in 0. It should be 200. It's decreasing based on the rate. And plugging in 0. If I plug in 0, we get 200. If I plug in 4, we get 12.5. Okay? So set up your ratio, 12.5 minus 200 over 4 minus 0. Get my calculator. I'm just going to plug all this in one lick because I'm getting lazy. I plugged all that in and I get negative 446 point, I'm just going to put 88. And put that right here. Okay? And right beneath that is those inequalities again. So 2 goes here for the y-intercept. Over here it's 200. Obviously 200 is greater. If I plug in 3, I get 54 over here. And I get 25 over here. So, boom, there we go. And we just calculated that. That was 40. This was negative 46.875. And that makes sense because it's going down. So obviously, hear me out when I say this, the greatest rate of change, okay, is going to be this way. I know it's a negative, and you know negative should be smaller, so this wouldn't make sense, but that negative is just telling us the direction, okay? 46 is greater than 40, but as far as direction, it's decreasing, but it has a more rapid change, okay? It has a greater rate of change, even though it's negative. All right, I think that's all of it. Holy cow, let me check. No, that doesn't help. Push this button. Ooh, we'll get into that later. Guys, this thing was 30 minutes long. I'm going to cry, so get to work. When you're done with this, you can work on your Chromebooks, Reflex, USA Test Prep, Gizmo, you know the drill. All right, good night.